Hello and welcome to today's lesson. In today's lesson, we're going to discuss the types of correlation, which is another way of describing trends in a scatter plot. We've already had some discussion on this. We're going to continue. The first thing we're going to talk about is strong versus weak versus no correlation. When there's strong correlation, the data would be close to a line or curve of best fit, like in our first example here. If I were to draw an oval around the data, the oval is small and close to the line of best fit. In my second example, I can draw a line of best fit and an oval around my data. Notice in the second case, the oval is wider, meaning the line of best fit is less accurate of a predictor. In the third case, I can't actually draw a line of best fit. There's not a lot of data for me to figure out a trend and what's outliers. In fact, I would draw a circle around the data. In this case, we would call that having no correlation. We are unable to predict what the trend is going to do next. To summarize, the first example shows strong correlation, the second example shows weak correlation, and the third example shows no correlation. Feel free to pause the video now while you write down the definitions that you see on the page for strong, weak, and no correlation. Remember, this tells us how accurately we can predict what's going to happen at any point from our scatter plot. The next way that we describe our correlation is by discussing the linearity of the correlation. If something is linear, like in our previous examples, then it makes a line of best fit. But if you can see a curve of best fit, then it is nonlinear. Each of these cases shown below are nonlinear. The one in the middle would be a strong nonlinear correlation. The other two would be moderate. The data is close to the curve of best fit, but it's not too close. It is slightly spread out. Take a moment now, pause the video, and write down the definitions for linear and nonlinear correlation. The final way that we discuss the correlation of the trend in the data is discussing positive versus negative correlation. When we're talking about positive versus negative correlation, we're talking about the direction that the data increases or decreases from left to right. So if we have positive correlation, the line of best fit would increase as we move to the right. If we have negative correlation, the line of best fit decreases as we go to the right. In other words, we're talking about what the slope of the line of best fit would be. My first example here has no correlation. Something with no correlation is neither positive nor negative. The second one, as we see, we could draw a line of best fit that decreases as we move from left to right. This one has negative correlation. And because the data is very far apart, it's a weak correlation. And because we draw a line of best fit, it is linear as well. It should be noted that a nonlinear graph can be weak or strong, but isn't necessarily positive or negative, especially if it's increasing on part of it and decreasing on another. Now our third example here we can see the data is close together, so it'll be a strong correlation. I can draw a line of best fit, so it is a linear correlation. And as I move from left to right, it increases, which gives us a positive slope to our line of best fit, so a positive correlation. This last example has a strong positive linear correlation. Now there are other examples that can occur where we can't tell what the correlation is. For example, if we had a graph and we had just a handful of data values, in that case, we can't tell what the correlation is. There's not enough data. Just 3 or 4 data points is not enough for a scatter plot. Another example where we see no correlation is if we have a straight line of data. If we have data that doesn't change one variable as the other variable changes, that tells us that the y does not depend on the x. And so we can't have a correlation in that case as well. And that's today's note. Thank you very much and have a wonderful day.